This is a video featuring astronomical images I've been able to capture with my smart telescopes. For some background on my history with astronomy, my equipment, etc., please see the introductory video to this series, link at the top right of your screen. To continue reviewing some imaging results I've been able to obtain using my various smart telescopes, I thought I would next turn my attention to the Cygnus-Sagittarius arm of the Milky Way, which is rich in deep sky objects ideal for astrophotography, including nebulae of all major types. These are the smart scopes that I currently own and work with, and I'll be showing images here captured with every one of these scopes. However, there will naturally be more from the scopes with which I feel I've had the best success. Here's a general view of the whole Cygnus-Sagittarius arm region, as it might be seen in the small hours of a spring morning. This area continues to be observable progressively earlier on summer nights, and parts of the area can even be observed in midwinter. I've ringed and named in red each of the objects whose images I'll be showing. However, covering all of those objects would likely make this video too long, so I'm going to be splitting my coverage of this region in two. In this video, I'll be dealing with the objects that rise first, those enclosed in the red rectangle here. The objects further down the Milky Way arm, enclosed in the green rectangle here, will have to wait for a subsequent video. Going in a bit closer, here's that upper area in more detail, and here I've inserted miniatures of some of my own images where the objects I'll be showing are located. I've added one extra object, the Iris Nebula, as it does fit in with this observing area quite well. This is an image of the Iris Nebula, NGC 7023, processed from 15 minutes of data I took with my Celestron Origin 6-inch RASA scope on January the 9th, 2025. This is a rather tricky object to image, or to observe visually for that matter. It was first observed and documented by William Herschel in 1794. It's a reflection nebula with a bright star at the core and extensive dust clouds. In this case, I tried to image it with a duoband filter in place, and this didn't work well, as the filter cut too much of the light from the nebula. Here's an image of the Iris Nebula, captured with about 25 minutes of exposure with my Unistellar Equinox 2 scope, a 4.5-inch reflector. This image was processed by the scope's own software. Unfortunately, the scope had gone out of collimation, so the left side of the image is out of focus. Here's an image from around 15 minutes with my C-Star S50, stacked from the raw frames and processed with Graxpert, Cyril, Cosmic Clarity and GIMP. Here's an image taken with the Celestron Origin on January the 26th, 2025, this time with just an IR cut filter, which helps with the light pollution. And here's an image from that same raw data stacked and punched up to reveal as much detail as possible. The blue light of the bright young star, i.e. only a few 100,000 years old, is reflected from the gas and dust around the centre. Further out, dust obscures the stars behind. The stars that are seen in the dark parts of the nebula are stars that are closer to Earth than the nebula itself, which is located about 1,300 light-years from Earth. Visually, the Iris Nebula is located in the constellation Cepheus, a king in Greek mythology. Here's an image of the Bubble Nebula, NGC 7635, from 20 minutes of frames captured with the Celestron Origin on March the 26th, 2025, no filter. This image was produced by the scope's own software. You can barely see the bubble in the centre. Here's an image from 25 minutes of exposure with the Celestron Origin on December the 14th, 2024, with a duoband filter. This is the image as processed by the scope's own software. And here's a version from that same data stacked and processed by me using my usual range of software. Here's an image of the Bubble Nebula from 20 minutes of exposure with my Equinox 2 4.5-inch reflector on June the 2nd, 2025. The scope was going out of collimation, so the left side of the image is a bit iffy. Here's another attempt with the Origin, this time for 25 minutes of exposure with a nebula filter on May the 9th, 2025. This is the final image as produced by the scope's own software. And here is a version produced from that same raw data using Cyril, cosmic clarity, etc. The Bubble Nebula is an emission nebula, gas cloud emitting light as atoms are stimulated by radiation, in the constellation Cassiopeia, so it's circumpolar and visible year-round in the northern hemisphere. The bubble effect is caused by stellar wind from a massive young star, young in universal terms, meaning less than 100 million years old or so. There's some dispute as to how far away this is, somewhere from 7,000 to as far as 11,000 light-years from Earth. Here's an image of the Wizard Nebula, NGC 7380, processed from 25 minutes of frames captured with my Celestron Origin on May the 20th, 2025, using a Celestron nebula filter. This is the final image as produced by the scope's own software. And here is a version processed from that same raw data using Cyril, cosmic clarity, etc. NGC 7380 is a young open cluster of stars in the northern circumpolar constellation of Cepheus. The cluster was discovered by Caroline Herschel in 1787. The surrounding emission nebulosity is known colloquially as the Wizard Nebula. German-born astronomer William Herschel included his sister's discovery in his catalogue. It's extremely difficult to observe this visually, usually requiring very dark skies and some kind of filter. The NGC 7380 complex is located at a distance of approximately 8,500 light-years from Earth in the Perseus arm of the Milky Way. Here's an image of the Elephant's Trunk Nebula, my first attempt of the year, from 8 minutes of frames captured with the Origin using a nebula filter on January the 8th, 2025. This is the final image from the scope's own software. Here's another attempt, again with the Origin, this time for 20 minutes with a nebula filter on January the 10th, 2025. This is quite a tricky object to capture, although the main trunk structure shows up quite readily. Here's an image from that same data, stacked and processed from the raw frames. And here's another attempt, again with the Origin using a nebula filter, this time for 35 minutes on May the 9th, 2025. And here's a version processed from that same raw frame data. The fainter nebulosity around the trunk is hard to bring out. Now here's a wide-field image of the area around the Elephant's Trunk Nebula, processed from about an hour's worth of frames captured with my Dwarf 3 on May the 20th, 2025, using the Dwarf's duoband filter. And here's a version stacked and processed from that same raw Dwarf data. The Elephant's Trunk Nebula is another complex of gas and dust clouds in which stars are being born. It's about 2,400 light-years from Earth. Visually, it's seen in the constellation Cepheus. The red is the result of hydrogen emissions stimulated by the radiation from young stars. The dark patches are caused by dust clouds obscuring the stars and glowing gas behind. I've never been too clear why this is called Elephant's Trunk. I suppose the elephant will be sort of looking from right to left here. Here's an image of the Cocoon Nebula, IC 5146, from 10 minutes of frames captured with my Celestron Origin on January the 9th, 2025, using a nebula filter. This is the version produced by the scope's own software. Here's a version from that same raw data, stacked and processed with Cyril, Graxpert and GIMP. And here's that same image sharpened and denoised using cosmic clarity. Finally, here's an image of the Cocoon Nebula from 15 minutes with my Equinox 2, no filter. This image was produced by the scope's own software, and I couldn't do any better processing the raw data myself. The Cocoon Nebula, IC 5146, is an emission nebula visually located in the constellation Cygnus, the Swan. From Earth, it is in the direction of the galactic plane of the Milky Way, and so there's a very dense star field behind it. The dark area around the emission nebula doesn't represent an absence of stars, but rather is caused by dust clouds surrounding the emission nebula and blocking out the light of more distant stars. The dark area in this case is actually separately designated as Barnard 168. There seems to be some doubt as to the exact distance, but this nebula is located somewhere around 3,000 light-years from Earth. Here's an image of the North America Nebula from 15 minutes of exposure with my celestron origin on January the 9th, 2025 with a nebula filter. This is the final image as produced by the scope's own software, so basically what you get without doing any image processing yourself. Here's a version produced by doing a bunch of processing on that final image produced by the Origin software. And here is a version stacked from the raw frame data, same root data as the previous two images. And here's that stacked version with additional sharpening and denoising using cosmic clarity. Unfortunately, the field of view of the Origin is too small to really capture the classic shape of the North America Nebula, which covers a lot of sky. So you can see a bunch of nebulosity in this image, but you'd be hard-pressed to say what object is being imaged. The North America Nebula is part of a massive interstellar cloud of ionized hydrogen visually located in the constellation Cygnus, the Swan. Based on observations in the second half of the 20th century, it was determined that the North America Nebula and the Pelican Nebula, which we'll be looking at in a minute, are actually parts of the same gas cloud, with the intervening dark area resulting from obscuring interstellar dust. Here's an image of the North America Nebula from approximately 32 minutes of capture with my Vespera Pro on April the 27th, 2025, with a duoband filter. This is the final image produced by the Vionis software. And here is a version processed from the same data with Graxbert, Cyril, Cosmic Clarity and GIMP. You can see the reason for the North America name here, though the nebulosity didn't come out as clearly as I expected with over 30 minutes of exposure. Here's a wide view of the North America Nebula from 50 minutes of exposure with my Dwarf 3 scope on April the 17th, 2025, using the IR cut filter. And here's my final version from that Dwarf 3 data stacked from the raw frames and processed. The whole of the North America Nebula didn't quite fit in, but you can see the shape quite well, and at the right is the Pelican Nebula, actually part of the same gas cloud with a dark division from the North America caused by interstellar dust. This nebulosity is spread over a large area of the sky and is quite faint, not visible to the naked eye. It wasn't documented until William Herschel observed it from Slough, England in 1786, using a telescope that was large but not very good by modern standards. Making high-quality mirrors and lenses for telescopes took quite a while to develop. Early mirrors were made from polished metal, hard to get the surface exact and considerably less than 100% reflective. The nebula didn't get its name until the similarity to a map of North America was noted by German astronomer and astrophotographer Max Wolf in 1890. This is another region of our own galaxy, the Milky Way, where stars are being formed. The North America Nebula is about 90 light-years from north to south and contains many thousands of stars, with more being born from the clouds of interstellar material. This nebulosity is visually seen in the constellation Cygnus. Physically, it's located in an arm of the Milky Way about 2,500 light-years from Earth. Here's an image of the Pelican Nebula from 15 minutes of exposure with my Celestron Origin on January the 10th, 2025 with a nebula filter. This is the image as output by the scope's own software, and from this you'd be inclined to call this capture a failure. However, nil desperandum. Here's the result after stacking and processing that same data. Although the nebulosity could hardly be seen at all in the version output by the scope's own software, it came up quite nicely when processed. And here's a final version, sharpened and denoised using cosmic clarity. I guess you could say I've gone a bit over-dramatic with the processing on this one, but I was only trying to provide a good view of what the scope captured. As noted, the Pelican Nebula IC 5070 is part of the extensive star-forming gas clouds visually found in the constellation Cygnus, the Swan, now considered to be part of the same gas cloud as the North America Nebula, with the gap between them resulting from intervening dust clouds blocking the emission light. This image was produced using the mosaic mode of my C-Star S50, since the narrow field of the S50 is really limiting for capturing larger targets such as this without making a mosaic. I also had the S50 set up in EQ mode for this capture. Unfortunately, the C-Star mosaic mode is very slow. About 1 hour of exposure went into this image, and that took about 2 hours to capture, and even then the mosaic was quite some way from complete. I restacked from the raw data and processed, and this was the best final image I could produce. It's quite noisy around the corners, as there really wasn't enough data captured there. This was captured using the S50's built-in low-pass filter. And finally, on the Pelican Nebula, here's an image captured with my Dwarf 3 with about an hour's exposure on May the 20th, 2025, using the Dwarf's built-in duoband filter. The Pelican Nebula is at the centre, and at the left is part of the North America Nebula. These gas clouds are located in the Sagittarius arm of the Milky Way, something like 2,000 light-years from Earth. Now, here is an image taken with my Celestron Origin on May the 9th, 2025, 20 minutes of exposure with a Celestron nebula filter with a gibbous moon. So far as I can tell, this nebulosity doesn't even have a name as such. I happened to image it just by pointing the Origin at an area that looked interesting. Here's the result from that same data after stacking and processing the raw frames. This is part of the nebulosity around the central star of the constellation Cygnus, named Sadra. So the whole area is known as the Sadra region. The bright star in the middle of this image is not Sadra, which would be off to the right out of frame. I think this illustrates how even small amateur telescopes can show quite spectacular regions of the sky beyond the traditionally well-known objects. Finally, on the Sadra region, here's an image captured with my Dwarf 3 on May the 20th, 2025, 40 minutes of exposure with the Dwarf's duoband filter. The bright star at the centre of this image is Sadra, Gamma Cygni, so this image shows the whole Sadra region quite well. The previous Origin image captured the bright nebulosity at upper left in this image. This is, of course, emission nebulosity, light emitted from gas clouds stimulated by radiation from young stars with extensive dust lanes. Just to the west of the Sadra region is the Crescent Nebula, also known as NGC 6888, Caldwell 27, and Sharpless 105. Here's an image of the Crescent Nebula from approximately 16 minutes of exposure with my Equinox 2 scope on June the 2nd, 2025, no filter. This is the image produced by the scope's own software, and I couldn't really do any better with the data. Here's an image of the Crescent Nebula from 10 minutes of capture with my Celestron Origin on May the 9th, 2025, with a Celestron Nebula filter. This is the final image produced by the Origin's own software. And here is a version stacked and processed from that same raw data, including the use of cosmic clarity. The Crescent is an emission nebula in the constellation Cygnus, about 5,000 light-years away from Earth. It was discovered by William Herschel in 1792. It's formed by the fast stellar wind from the Wolf-Rayet star WR136 colliding with and energizing the slower-moving matter ejected by that star when it became a red giant around 250,000 to 400,000 years ago. So it's a bit like a supernova remnant, but resulting from a matter ejection less substantial than in the case of a supernova and at a different stage in the star's life. Finally, to the last object I'll be covering in this video, the Ring Nebula, catalogued as Messier 57 and NGC 6720, seen here in an image from about 8 minutes of exposure with my Equinox 2 on June the 2nd, 2025, no filter. This is the image produced by the scope's own software. I couldn't do better with the data. The scope was going out of collimation, so the left side of the image is out of focus. Here's an image from 5 minutes of exposure with my Celestron Origin on May the 9th, 2025 with a Celestron Nebula filter. This is the image output by the scope's own software. And here's a version from that same data stacked from the raw frames and processed. The Ring Nebula is a planetary nebula in the northern constellation of Lyra. Such a nebula is formed when a star, during the last stages of its evolution before becoming a white dwarf, expels a luminous envelope of ionized gas into the surrounding interstellar space. This nebula was discovered by the French astronomer Charles Messier whilst searching for comets in late January 1779. Following on Messier's report, fellow French astronomer Antoine Darquier de Pellepoix independently rediscovered the nebula whilst following a comet 2 weeks later. Darquier reported that it was as large as Jupiter and resembles a planet which is fading, which may have contributed to the use of the persistent planetary nebula terminology in the years since. Messier and German-born astronomer William Herschel speculated that the nebula was formed by multiple faint stars that were unresolvable with their telescopes. In 1864, English amateur astronomer William Huggins examined the spectra of multiple nebulae, including M57, and discovered that they displayed the bright emission lines characteristic of fluorescing gases. Huggins concluded that most planetary nebulae were not composed of unresolved stars, as had previously been suspected, but were nebulosities. The Ring Nebula was first photographed by the Hungarian astronomer Eugene von Gotthard in 1886. So that's it for this video. If you have any questions either about my equipment and methods or about the astronomical objects imaged, please post in the comments below and I'll do my best to respond. I will follow up with a second part covering the objects further south in the Sagittarius arm when I get a chance. Until then, clear skies.